Good day, everyone. Today we're going to be in discussion of the physical sciences, grade 10, term 3, scope. So within the first week, we're going to be learning about the chemical change, quantitative aspects of chemical change, define concentration, calculate concentration in mole per decimeter using C equals to N over V, determine percentage composition of an element in a compound, determine the empirical formula for a substance from percentage composition, define an empirical formula as the simplest, determine the number of moles of water of crystallization in salts like CuSO4 5H2O, define water of crystallization. Within the second week, we'll be looking in the chemical change, which focus on the following: perform stoichiometer calculation based on balanced equation, just like concentration, mass, moles, molar mass, number of particles, and volume. Determine the theoretical yield of a product in a chemical reaction when you start with a known mass of reactant. Determine the percentage yield of a chemical reaction. Within the third week, we look at the mechanics, the vectors and scalars. List physical quantities, for example, time, mass, weight, force, charge, etc., etc. Define a vector and a scalar quantity. Represent vectors graphically with an arrow. Use the force vector as an example to show equality of vectors, negative vectors, and addition of vectors in one dimension only. Define a resultant. Determine a resultant graphically using a tail-to-head method, as well by calculating for maximum of 4 force vectors in one dimension. Within the fourth week, we dive into the mechanics motion in one dimension. Describe the concept of a frame of reference. Define one-dimensional motion. Define position relative to a reference point and understand that position can be positive or negative. Within the fifth week, we learn about the following: define distance, displacement, describe and illustrate the difference between displacement and distance, calculate distance and displacement for one-dimensional motion, define average speed, average velocity, calculate average speed and average velocity for one-dimensional motion. Within week 6, we define acceleration, which is A equals to delta V over delta T. Differentiative between positive acceleration, negative acceleration, and deceleration. Calculate acceleration in one-dimensional motion. Within week 7, we look into the mechanics in the speed and velocity and the equations of motion. Define instantaneous velocity and instantaneous speed. Describe in words and distinguish between motion with uniform velocity and uniformly accelerated motion. Describe the motion of an object given its position versus time, velocity versus time, and acceleration versus time graph. Determine the velocity of an object from the gradient of the position versus time graph. Within week 8, we determine the instantaneous velocity at a particular time using the gradient of a tangent to a position versus time graph. We determine the acceleration of an object from the gradient of the velocity versus time graph. Determine the displacement of an object by finding the area between the time axis and the graph of a velocity versus time graph. Within week 9, there will be you'll learn the following: use the equations of motion listed below to solve problems involving motion in one dimension in the horizontal plane only. These are the equations that you're going to be using. Solve problems for the motion of vehicle, including safety issues such as relationship between speed and stopping distance. Within week 10, you're going to dive into the mechanics, which talks about energy. You're going to be learning more about the following: define gravitational potential energy of an object, calculate the gravitational potential energy of an object using E, P, which is potential energy, equals to mgh, or U equals to mgh. Define kinetic energy of an object, calculate the kinetic energy of an object using EK equals to half mv squared, which stands for kinetic energy equals to half mass times velocity squared, or K equals to half mv squared. Within week 11, you'll be done within everything that is provided for within the scope, and you only have one paper which is out of 100 marks, and we are going to have a control test which has the following: quantitative aspects of chemical change, vectors and scalars, motion in one dimension, instantaneous speed and velocity, and energy.